Hello everybody and welcome back to another episode of Tableau Tip Tuesday, the series where we break down issues into their base components so that we can understand and implement them better. From beginner to expert, this is a great series for you to find those hidden gems you may have missed to take your visualizations to a new level. This is going to be part one in our workbook performance mini-series here, so if you're looking for data structure or server architecture, I'll save you some time. This is not the video for you. We're going to be focusing on our workbook performance, and part one is going to focus on calculations specifically. So without further ado, let's go ahead and get to work here. Alright, so the first thing that we want to understand here as we start our series off is there is a really helpful tool that Tableau provides called the Performance Recorder. So if I go up to my Help menu, Settings and Performance, and I start this performance recording, it's going to start analyzing everything that I do as I build this dashboard. So we're actually going to start this right here so that at the end of this whole thing we can take a look and hopefully prove that some of these calculations are more efficient than others. So I'll go ahead and get that started right here. First on our list here is going to be row level versus aggregate calculations. So if I go to this worksheet here, I have a couple of calculations that I have pre-built. If we just go ahead and take a peek, you can see that this one is aggregated right here. I'm just multiplying sales times 1.08 kind of to highlight a point here. And then my other calculation is just the row level version. Now both of these calculations are going to give me the same results right here, but my aggregate calculation is going to be a little bit more performant. The reason being is because an aggregate calculation has fewer computations to have to do to arrive at the output, and we'll break that down here in just one quick minute. But we can see that as I toggle back and forth between these two sheets, it's on two sheets just so that the performance recorder can analyze them individually. You can see that we have the same results. Now that's not always going to be the case here, so when we have a row level calculation as a ratio, so I have a couple more calculations right here. If we take a peek at these, this is just nothing more than a profit ratio. You can see this is my aggregated version as my title suggests. And if we press OK, my other one is just the row level version. Now, when we have a calculation that provides a ratio, remember that it's basically just adding on a column to my data set. So for that reason, it's going to try and say that you offered 2 instances of a 10% off sale. Well, the sum of that is going to be 20%, and it's going to give me a heavily inflated result. So if I take my aggregated version out to text, and we format that as a percentage here real quick, there we go. You can see that this will be my true profit ratio per category. However, when I use my row version over here, and I take this to text and we format that as a percentage, you can see that it is a heavily inflated values based on the fact that it's going to want to sum ratios, and that doesn't really work very well. So what does this have to do with regards to performance? I have a quick Excel workbook. It just simplifies what we just went through right here, where we just have 5 sales. We have the sales, profit, and profit ratio for each column. Now my row level calculation is providing me with this column right here. So what Tableau is obviously going to want to do is sum those values. So it's going to be a sum of these values right here, and this is where that heavily inflated value comes from, 199%. So this always begs the question, hey, can I just take an average of this amount? The answer is no. It's going to give you what's referred to as a visible average right here. So it doesn't care the dollar value of the sale or the profit. The only thing it cares about is that ratio. So if we take our result right here and divide it by 5 for our 5 transactions, we can see we have a visible average of about 40% right there. Well, if we take our weighted average, which again would just be the totals of each column and dividing them against each other, so we can take this divided by this, we can see that we have a 44% weighted average. Now, as I change one of these transactions, so I'll take this $10 transaction and turn it into 100 and change my profit into 20 so that it has the exact same ratio, well, now you can see that my weighted average adjusts based on the weight of the dollar value that went into it. And if we take it back to Tableau, we can indeed see that if we change this sum to an average right here, it is not going to give us our true profit ratio, rather an average of averages. So again, what does this have to do with performance? Well, in order to arrive at this visible average right here, it had to computate all 5 of these profit ratios going across right here, and then a 6th computation to sum them up, and a 7th computation to average them. Now our other weighted average down here is only going to take a total of 3 calculations. one to sum up my sales column, one to sum up my profit column, and then one to divide the two to give me my weighted average. So our visible average took a total of 7 computations, and our weighted average took a total of 3. You're probably saying, big whoop, why does that matter? It's only 4 computations, and Tableau is quick at these things. Well, extrapolate this out. If we had 100 sales, then our visible average would take 101 computations to arrive at the visible average, whereas the weighted average will only take the same 3. Now that is true with regards to ratios or the previous computation that we saw, sales times 1.08. It's the same either way. So row level will always just be a little bit less performant than their aggregate counterparts. All right, next on our list are data types and speeds. So if I go to our next graphic here, you can see our data types listed over on the right, and then whether they're faster or slower. So a Boolean is going to be my fastest data type, and a string is going to be slower. Now this has implications all over Tableau. We're going to visit one of them, and we're going to take a look at our parameters here. So our goal here is we want our ending user to determine what disaggregates this chart. So in our instance, we're going to choose either region right here or subcategory right here. So we have a parameter set up, and if we take a peek at these parameters, they're the exact same parameter, just set up with different data types. This one is passing a string value to my calculation, and my other parameter is passing an integer instead, 1 and 2. So remember that everything to a computer is still ones and zeros, so when you pass a string to that parameter up here, which I also have pre-made, you can see that the integer parameter is only passing an integer, which is going to take far less processing power than its counterpart over here, its string counterpart, where we can see we're passing the variable of a string right here. So you're probably talking about a small amount of speed, but say for example we had more than just 2 dimensions cased out in this parameter. We could potentially have 5, 10, or 15, and then you're going to have cascading effects when you choose the correct data type. All right, so let's go ahead, and again, the whole idea of this is to have our performance recorder show us if we're saving any speed, so we can ensure that that works right here, and then we'll go into this one over here, and we'll do the string version, show that parameter control, and again, my performance recorder is logging all the time it takes to do all this in the background, so we should see some slight differences. Last thing that we have for you is going to be nesting if statements here. So I have a couple of things that I want to share about this. First things first, if you ever have an else if statement, so you can see here that we have 3 different clauses in my if statement. If I have an else if statement, it will go faster if I do not put a space in between my else and my if. The reason is because if I put a space right here, it is starting a new if statement. Whereas if I have no space, it recognizes this if automatically as a child of this if. So that right there will save you just a little bit. And the next thing that we want to talk about is the ordering of our clauses. So if we look at our background visualization back here, we can see that it is a number of records that exist within each given category. So since my office supplies has the most number of records, it behooves me to place it first in my if-then statement. That's because when it runs this clause and determines that it is an office supply, it does not continue to run each subsequent clause. It will terminate the if statement and move on to the next row. So if we have to go through 2 failed clauses before we get to our successful, it's going to take Tableau just a little bit longer. So whatever is going to capture the most results, place that first in your if-then statement. All right, last but not least, I know I said we were not going to be going over anything with regards to the data model, but I just couldn't pass up the opportunity to tell you guys about extracts. If we right-click our data source up here and go to an extract right here, there's a really cool option that we can go to called Aggregate Data for Visible Dimensions. This is simply going to look through your workbook and determine the dimensions that you've used and remove anything that you have not used. So if there's a column that you haven't used, or maybe you only use dates up to the month level, you can steal back a lot of performance back just by using these right here and extracting fields that weren't used. So now after all that, if we take a look at our performance recorder that I have open right here, the results aren't as exciting as I would have liked, but you can see the difference between all of the different calculations that we did there. There you go, our row level just taking a little bit longer in each instance. Our first parameter going a little bit faster than our second. Again, it was a small data set that we did this on, but you can get a sense for all the inputs and ideas that you can get for what may be causing you any performance issues from the report that you get, again, from the help, settings, and performance menu right here. Alright, hopefully you found something useful that you guys can take back to your dashboards. That's all we have for you guys today. Join us next week for another tip.